When dealing with rational functions, which look very similar to a fraction, we know that one of the first things we want to do with fractions is to simplify them, or to put the fraction, or in this case the rational function, in its simplest form. So the first thing that I'm going to do whenever I see a rational function is I'm going to see, will it possibly simplify? Just like I can take the fraction of, say, 2/4 and simplify it to 1/2 by dividing both the numerator and the denominator by 2. Now, with a rational function, that does get a little bit more complicated, and oftentimes will require you to factor the numerator and the denominator. So I'm going to do that first. I notice in the numerator x squared plus 7x that I have a common factor of x, and so that leaves me with x plus 7. In the denominator, it may be a little bit more complicated, so I'm going to come off over here to the side. X cubed minus 5x squared minus 14x, and do some scratch work. I do notice that all three pieces have an x, so I'm going to factor it out. That leaves me with x squared minus 5x minus 14. So I have the x out front, and then I need to break down the quadratic. I need to find a pair of numbers that will multiply to 14 and subtract to 5. So I believe that will be 7 and 2. I need a -7, or end up with a -5, so the 7 is negative, the 2 is positive. So in the denominator, once it's factored, I have x times x plus 2 times x minus 7. I notice that in the numerator and the denominator, I have a common factor of x, which is going to divide out. That x that divides out, x would equal 0, becomes a removable discontinuity. Removable in the sense that it divides out when I simplify the rational expression. But I still could not use 0 in the original function. So that's why it's a discontinuity. It means I can't really use that point. So visually on the graph, and I'll try to sketch it here for you so you can see it visually, if you were looking at the graph of this function, what would happen is that at the value of 0, I would have basically an open dot or a little circle to show that I couldn't use that one individual point. Then, once I get my fraction simplified, so now I've simplified my rational function, and it is now f of x equals x plus 7 over x plus 2 times x minus 7. The second thing that I want to do after I've simplified, and the simplification leads me to that removable discontinuity, I need to find the vertical asymptotes. To find the vertical asymptotes occur at the values that make the denominator equal to 0. So to find the vertical asymptotes, the denominator cannot equal 0. So I would have the expression x plus 2 cannot be 0, or the expression x minus 7 cannot be 0. And I'm going to solve each of those individually for x. Subtract 2. So you get x cannot be negative 2. And then solving the other one, I add 7 to either side. So x cannot be 7. These two, which are expressed as x equals, which is the form of the equation of a vertical line, these two create my vertical asymptotes. Now visually, if you're hand drawing the graph, we typically draw the vertical asymptotes in using a dotted line. So I would have visually a dotted line at negative 2, and I would also have one at 7. Now the asymptotes act like a kind of like a fence, and your graph can get really close to the fence, but you can't cross it or touch it. Now, we also could have a horizontal asymptote here, and just as a side note, with a horizontal asymptote, you have to compare the highest exponent in the numerator with the denominator. The numerator, that highest exponent is 2. The denominator, the highest exponent is 3. Since 2 is less than 3, there is a horizontal asymptote, and it occurs at y equals 0, which is your x-axis. Okay, so there's also visually here a horizontal asymptote, and again, we usually dot that particular line in if we're drawing it by hand. Now, if you're looking at that particular equation on a computer-generated or a calculator-generated, graph of that, typically your calculators do not actually draw in or dot in those vertical asymptotes. But again, to find the removable discontinuity, you want to simplify your rational function. The expression that simplifies out, you set equal to 0 and solve, and that becomes your point of discontinuity. To find the vertical asymptotes, you let the denominator equal 0 or it cannot equal 0, and you solve for x.